Hi everyone, welcome back to Data Hikes. We looked at the entity relationship model and its various components in the last lecture. Today, what we will be going over is problem solving for an ER diagram, which basically means we have a statement written in plain English as you might see in an exam for drawing an ER diagram, or like you are going to face in the real world where you need to build database systems. The description is going to be in a plain English language, and you're going to have to build a database system out of it. So we'll just learn with a very simple example how to think about this when we convert a problem statement to an ER diagram. Let's look at a very simple problem statement that we have here. It just says students register for courses and courses have tests. Courses are assigned to various professors. Now, this is very limited information that we have here. In a real world system, you can have much more information in much more detailed. Also, if you don't have that information, you have the opportunity to ask that information. So you need to ask whoever is in charge or whoever is asking you to build this database system various questions, various specifications of this question, and you'll be able to get a better statement, better problem statement out of it. In this case, assuming this is all the data we have or all the information we have, we'll try to build an ER diagram based on this information that we have here. The first step in building an ER diagram is identifying the entities. Basically, kind of identifying the main players in this database system. The very basic thing to do here is just notice all the nouns in the statement. Especially when the statement is this simple, it is safe to say that most of the nouns here would actually convert to entities. A few may be attributes if we have more detailed information or detailed description about the problem. Then we may have some nouns that are actually attributes in here, but let's see if that's the case. The words we have, the nouns we have in this statement are student, course, test, and professor. All of these seem like major players in this particular problem statement, because students and professors are physical objects or tangible beings. And if you remember from the last lecture, the entities are basically physical or conceptual objects. So in this case, students and professor can be called physical objects as they are tangible, and then courses and tests are more of conceptual objects. They don't have direct physical representation, but by themselves they mean something. So that means that they are conceptual objects. The entities are represented using rectangles in an ER diagram from, if you remember from the last lecture. And this is how we would represent the four entities that we have identified in this problem. The second step is to identify relationships. Most verbs and their following or preceding prepositions between entities in a database problem are relationships. Students register for courses. For example, we can look at each section of the problem one by one. Students register for courses. We have two entities here, student and courses, and the verb phrase between the two is register for. Hence, we can build our first relationship, which is represented by a diamond in an ER diagram, something like this, where it's connected to each entity on both sides. As we know, the statement is kind of read from left to right. So student register for course. This is the first relationship we have. The second one is courses have tests. This is the second part of the statement and the second relationship that we can look at. Courses is the entity here. We already have that entity on the ER diagram. Test is the other entity. And the relationship between it is having or to have. So course has test is the second relationship that we have in this ER diagram. The third relationship is courses are assigned to various professors. We already have course in the ER diagram. The remaining relationship is assigned to, because that's between the entity of course and professor in this relationship. We still don't have professor in the ER diagram. Hence, we will add that relationship in here like this. Course is assigned to professor. Now, we basically have the skeleton of our ER diagram, and this is how the structure of the ER diagram that for this particular simple problem would look like. Next, we will assign cardinalities to the relationship. If you remember, what cardinality means is how many entities of each entity set participates in the relationship. There is one to many to one to one, and many to many cardinalities. Let's look at this relationship first. Let's do it part by part. Students register for courses. We can say one student can register for multiple courses. Of course, in most cases, a single student can register for multiple courses. I think that's a sensible assumption to make. And if we think about the same thing other way around as well, multiple students can also register for one course. So, if the conditions for both a one-to-many and a many-to-one relationship are satisfied by this particular relationship, then it is actually a many-to-many relationship, because one student can take multiple courses, but multiple students can also take one course. Hence, this relationship is many-to-many, which is represented by writing an M and an N on each side of this relationship. The second one is courses have tests. Each course may have multiple tests. Hence, this is a one-to-many relationship. We have not been told specifically that each course has one test or something like that. If we had the opportunity to learn more, we may find out, hey, how many tests would one course have, and questions like that. If it was just one test per course, then we might say this is a one-to-one relationship. But since we don't have anything specified, we would assume a normal scenario, and a normal scenario would say one course may have multiple tests. So this one-to-many in this direction is satisfied. Is many-to-one also satisfied? Can we say many courses have one test? I don't think that makes sense, because multiple courses would not have only one test, correct? So, because this is satisfied in only one direction for the one-to-many and not satisfied for the many-to-one, we can say that this is purely a one-to-many relationship. The third one is a course is assigned to professor. Here, can we say that one course can be assigned to multiple professors? Sure, there may be multiple classes for a course. We don't have that information completely. There may be cases where multiple different professors are teaching the different classes for the same course. Hence, we can say yes, one course can be assigned to multiple professors. Can we say the other way around? Can we say multiple courses are assigned to one professor? Sure, why not? Because it is not necessary that one professor is only an expert in one subject, or even if they are, it's not necessary that they take only that one course. So sure, multiple courses can be assigned to a professor, because the one-to-many and the many-to-one relationship both work over here. This is also a many-to-many relationship. Hence, we will be adding the M and N over here. The next step is basically adding the details to the ER diagram. We have the entire structure, this is all prepared, but now let's add descriptions to the entities in our ER diagram, starting from the first one over here, or in this case, when we say description of an entity, we know that that means attributes. Attributes, as we all have looked at, are represented using ellipses, and starting from the first entity student, the attributes would look something like this. Now, for a student, we can have so many attributes. One can think of a number of attributes that a student can have, but based on just no other information, we can just stick to the basics and stick to the most logical explanations of what attributes a student may have. The first attribute is the student ID. Just understand that most entities, except a very few, very rare instance of a weak entity, the entity will have some kind of unique identifier as one attribute. In this case, that would simply be the student ID. It is safe to assume that in a school system, there will be a unique identifier for each student. The other attribute we have is a name. Of course, logically safe to assume all students have names, and we have that attribute added over here. The third one is the level, the grade, the standard that the student is in. And for now, if we have no more details of the student, we can stick to just this basic information. The second entity we have is course. How would the attributes of course look like? The first is again course ID, the unique identifier for a course. The second, like a student, is a course name, because we need to have some kind of description of what will be taught in this course. So it's just the course name, whatever the name of this course is. The third one we have is assigned rooms. Now observe here that this is represented using a double ellipse, and like we studied, double ellipse means multi-valued attribute. Why is this a multi-valued attribute? Because for one course, there may be multiple rooms that different classes of the course take place in. Based on the schedule of the school, whatever, we can say that, oh, there can be multiple different assigned rooms for a single course. Hence, if for one course we can have multiple rooms, then this is a multi-valued attribute. Hence, these are the various attributes that we are using for course. The third one is the most interesting one, I feel, which is test. Let's look at the attributes for test. Observe here that the test ID is the unique identifier for a test. However, for each test, we also need to know the key attributes from student and course. So, course ID and student ID are also part of a test, because we need to know if a test is taken, what course was this test for and which student is this test for. So these two are connected by the course through the course ID to the student. This is directly connected to course ID, and then via course ID it is also connected to student. Hence, for one test we have the unique identifier as test ID. Observe here that the course ID and student ID are not underlined. If this was a one-to-one relationship, if we would have known that for each course there is going to be only one test, then we may not have required a test ID. This may have been a weak entity then, because it is related to student directly via course, because this is a one-to-one relationship. Now, then it would be the case that for one course student ID pair combination, there will be only one test. But we have said this is a one-to-many relationship. Maybe one course has multiple tests as we go through the year. That is why we have the test ID as its unique identifier along with these details for course and student. Alongside that, we have the score for that student's test for this particular course, and then we have the derived attribute grade. Now, we saw in the example when we saw the derived attributes, because grade can be derived from the score. If the student's score was say 95, the grade would be A. Because this attribute has meaning in and of itself, but it still can be derived from another attribute. It is using a dashed ellipse, and it is called a derived attribute over here. So these are the attributes for the test entity. Now the last one, professor. What are the entities, or sorry, what are the attributes associated with the professor entity? Let's just say the simple one would be employee ID. A professor is an employee of the school or university, and they have a particular ID. They also have a name, just like a student, professor would also have a name. And then we have the multi-valued attribute, publications going with a professor. If a professor has a PhD in some kind of research subject, it is very likely that they have some publications in journals. And this is again a multi-valued attribute because one professor may have multiple publications. Hence, this is how our entire ER diagram would look like from just the simple statement that we saw in the beginning, saying students register for courses, courses have tests, and courses are assigned to various professors. This statement helped us build this entire ER diagram, and this ER diagram can now be converted into a database system once we get to the coding part of things. Thank you for watching, and please give me any feedback you can on this lecture. I hope you enjoyed this, and I will be continuing with the database systems and SQL series as we move forward. But for now, this is all for the ER diagrams or ER model side. Thank you.